Hi guys, welcome back to Data Every Day. Today we'll be looking at a data set of face data, which I believe is faces of children, and we're going to be trying to classify their age, gender, and ethnicity based on, you can see the pixel data is just in a CSV file. So we'll be using that, and we'll be using convolutional neural networks to make our predictions. So let's get started. You can see I'm just importing these standard libraries, not too much here. It's just NumPy, Pandas, Plotly Express for some quick data visualization, and train test split function from sklearn. For the actual model building, we'll use TensorFlow. Okay, so let's import our data using Pandas read CSV function. We just get the file path over here, age, gender, CSV. Paste that in, take a look at the data. And we can see we have our target columns as the first three here. Some sort of index column we're probably not going to need, and then the actual pixel data, which will be our input. So I guess let's start pre-processing. Not too much to do here in the way of pre-processing, but we should take a look at if there's any null values. I assume there's not, but we should just make sure. And no null values. So next thing, we're just going to drop this image name column. So data equals data.drop image name. That's what it's called. Yeah. And specify the column access. Okay. Now let's notice something. Okay, we want to know what are the unique values in our targets. So in gender, we can assume that's 0 or 1, but we can't really see all the values in these ones. So why don't we just take a look at the unique values that we have. And there's a lot here. Let me actually just get it for all of them. So we'll do it with gender. We'll do it for I can just make instead of doing it this way, I'll just make one dictionary, which will be you'll map a column to a list of the column's unique values for each column in age. I'll do it in order. Gender, ethnicity, and age. Alright, so for gender we have 2. For ethnicity we have 5, and they're properly labeled. And then for age we have a bunch of different values, and I don't think this corresponds to years. I think it's on some other scale. So I think what we can do for age, why don't we bin the data? So discretize the data. We can use the pandas function qcut to perform a quantile cut of the column, which will take in the age column, and we want 4 bins, and we'll give it labels 0 through 3. That will look like this. It'll take it'll take this data, right, age, and it will bin it accordingly. So the lowest numbers will go in 0, the highest numbers will go in 3. And we can just assign age to that. Alright. So now if we took a look at this, we'd see age has 4 unique values, ethnicity has 5 unique values, and gender has 2. And so now our data is in a position to be fed into a model, or almost, just about. We still have to deal with these pixel values. Right now, they're currently a single string value in each entry. What we want to do is make a NumPy array or a tensor of with each one of these as its own value, and we should actually check how long is one of these. So let's get the length. The length of data subpixels of the first one dot split. So we're going to split on spaces. And this will give us the number of unique pixel values in the first element. And there's 2,304. So just to make sure that's the case for the other ones, yeah, it looks like they all have 2,304 pixels. And this, if this is a square image, let's hope it is, we can get the square root of this, of 2304, is 48. Okay, good. So now we can say, okay, image height is 48 pixels, image width is 48 pixels, and we'll just include num pixels equals 2304. Alright, and why don't I just add print statements so we can keep this in the notebook. Alright. So now we have this, and we can start processing our data. Okay, so why don't we split off our data? Alright, we're going to have y will be these three columns, and x will be this column. So y will just be data sub gender, ethnicity, age. And x will be, well actually, why don't we take this, make a new variable called target columns, paste it in there. Now we can just do data sub target columns, and x is data dot drop target columns. Alright, now y looks like this, and x looks like this. Just what we want. Now x needs a little processing, right? Why don't I keep that there? Okay, so we need to turn this first. First we need to turn it into, why don't we make it a series to start? So if we look at what that looks like, you can see this actually is still just a data frame with a single column. So let's just make it a series so we can work with it more easily. So x will be a series of that column. And looks like this. Okay, same as before, but now we have a series. Alright, so now we want to split. So what that'll do is we'll take each one of these, and instead of it being a string, we'll make it an array, a list. So pd, now we'll do x.apply a lambda function that'll take some x, which is a whole one of these, and it's going to return the list that we get when we split it by spaces. So do that, look at x. This actually might take a second, especially, yeah, this will probably be the longest part of the notebook. Alright, but we get it. And now, actually it's hard to see, but these are arrays now. Oh wait, no it's not. No, it is not. I have to actually apply it. Why don't we just take a look at it first? See what it looks like. And then after that, I'll just start typing this. We're going to apply another lambda function. So you can see, right now it's arrays. String becomes arrays, and these are actually still strings in there. So we got to make sure that these get turned into integers. So what we're going to do is iterate through this, and then apply a lambda function to each one. That's going to map its own lambda function that will turn each element into an integer. So x.apply, let's just set that equal to x, and this one will be x.apply, yeah, I'll run this, some lambda function that's going to take in an x, which will be one of these rows, and it's going to return the numpy array. Actually, I'll do it backwards. I'll say it's going to return, we're going to have to apply another lambda function, right? So we're going to map a new lambda function to each one of these. It's going to take in some z. We'll say z will be a single one of these. So x is the full row, and z is going to be 1. It's going to map some z to numpy.int of z. So we're just going to cast each one of these into an integer. And then this map is going to return a map object, so we'll cast that into a list. And then we actually want numpy arrays, so we'll cast that into a numpy array. Okay. And I will set this, I'll set x equal to this, and just take a look at it. Map must have 2 arguments. Right. I didn't actually mention what's being mapped, which will be the x of a given, so one of the rows. Okay, that's going. After that, we should get a numpy array of numpy arrays. And that's okay, but we want it as a single array. So we can use numpy.stack to do that. So I'll show you what that does. Numpy.stack, numpy.array of x. X is 0. So, okay, why don't we do it step by step. First we'll make it a numpy array. Wait, and I put this in the wrong. Okay. X is going to be a numpy array of x. Now we'll look at x. You can see it's an array of arrays. Now we just want it as a single array with multiple dimensions, so we'll use the stack function that will take all these different arrays that we have in there and stack them all on top of each other. So we have one array. And we're going to specify on the 0 axis so that it goes down here and stacks them this on top of this on top of this, like so. So that would look like this, which instead of it being an array of individual numpy arrays, it's one array that has multiple rows. So for example, if we look at the shape of this, this is a single vector of length 23,705, and this is a vector of a numpy array, 2-dimensional numpy array of length 23,705, but also has a width of 2,304 for each pixel row. Alright, so we'll set x equal to this. And now, one last thing, we want to, instead of having a full one-dimensional array of pixels, let's make it 2-dimensional. So we have the image height and image width that we got, which is 48 by 48. And we're going to reshape this now using numpy.reshape. So I'll just show you. We're going to reshape x, and we're going to give it a new shape. This new shape is going to be 3-dimensional. The first axis, first dimension, will be the number of training examples. And we can use -1 to infer that. It'll automatically fill this in for however long the longest dimension is. And then we're going to make it 48 by 48. So what that's going to do is it's going to give us a new one that is, what is it, 23,705 long, where each element, instead of it being a one-dimensional array, will be a 48 by 48 array. So that looks like this. Each element is now 48 by 48. See, this is 48, and there's 48 of these. And then that happens 23,705 times. So if we were to look at the shape of that, it would look like this. So now we have this many pictures, each one being 48 by 48 pixels. So we'll set x equal to that. And now, when that finishes, our x is... Oh no, I said equal to the shape. Okay. Let me just... I'm going to have to rerun all these. Okay. In the meantime, let's visualize. So this is going to be, we're just going to take a look at some of the images to see what we're working with. And for this I'll use matplotlib. So plot.figure, we'll give it a fig size of 10 by 10. And then for, we're going to iterate through a couple of random images from a dataset. So for index image, in enumerate, we're just going to make a random range here, random and numpy.random.randint, which will get integers between 0 and 1,000, and 9 of them. And we're going to enumerate that. So we'll get an index 0 through 9, 0 through 8 rather, and an image which will be a random index between 0 and 1,000. And we'll make a new subplot, which will be in a 3 by 3 grid. The index will start at 1, and we're going to use the image show function, imShow. That's going to take x at some image index, which will be a random one. And we'll turn off the axes. Alright, plot.show, and let's just look up here. Okay, this one wasn't run yet. So now we have x looking like this. This is perfect. Alright, let's just put these all in the same line so that we can just keep our notebook clean. And even this one. Alright. Okay. So basically, using imShow, it can take one of these 48 by 48 pixel data and create an actual image from it. And I didn't import matplotlib apparently. Okay. I is not defined. Oh, this should not be. This should be index plus 1. Alright. And so these are 9 examples of our image data. And if we run it again, we'll get 9 random more ones. 9 more random images. And you can see we're always dealing with pictures of babies. And I assume they have varying ages, but all young children. So we can build the models now, I believe. So we have some idea what we're working with, and we have all of our data in the right format. One more thing we might want to do. Let's split up. I guess we can do that down here. Let's split up our let's make 3 new output columns, or label columns. So yGender will be a numpy array of the gender column in y. Remember, y looks like this, right? So we're going to take the gender column, turn it into a numpy array, and store it in yGender. And we'll do the same thing for ethnicity. And we'll do the same thing for age. Okay, so now yGender would look like just a numpy array. So now we're dealing with numpy arrays only, and that's good. Okay, so let's take a look at x.shape one more time. So this is going to be our input size, 48 by 48, and this is the number of training examples. Alright, now we'll make a function called buildModel, and this is going to be building the Keras model and then compiling it so that we can do this once for each of the 3 models we need. Alright, so we'll do a pretty standard convolutional network, neural network. So starting with an input layer, which will be tf.keras.input, and we'll specify the shape. Shape will be image height, which is 48, by image width, which is also 48. And by 1. Because we're only dealing with grayscale pixel intensity values, we have 1 dimension there. Alright. Then we'll make our first hidden layer, which will be a rescaling layer. Well, this is just a sort of a preprocessing layer that will convert these values of 0 through 255 down into a range from 0 to 1. Okay, so layers.experimential.preprocessing.rescaling. And the factor by which we'd like to rescale is 1 over 255. And I include the dot for float division. We can pass in the inputs and move on to the next one. Now we'll start the convolutional layers. So we'll do 3 rounds of convolutional layers. tf.keras.layers.conv2d. That takes in, we'll use 16, and then kernel size of 3, and padding we'll leave as same. The activation function will make ReLU, and we'll pass in x. Alright, then we'll do max pooling after that. Layers.maxPooling 2D, passing in x. And so I'm going to one second. Okay. Yeah, I'm going to do this 3 times. Whoops. This time using 16 filters, this time using 32 filters, and this time using 64 filters. And that's pretty standard. After that, I'm going to flatten it. So we're going to bring it back down into 1 dimension. And so that is tf.keras.layers.flatten, passing in x. Then we'll have 1 fully connected layer at the end, layers.dense. We'll give it 128 activations and another activation of ReLU here, passing in x, before finally having our output layer, which will also be dense, except the number of classes is going to change based on which model we're training. So I'll call that num classes, and I'll include that as a required parameter in our function. Then our activation function will also change. We'll use sigmoid for binary classification, softmax for multiclass. So let's call this activation, which we'll also include here. But we can initialize that to softmax. And then, is there anything else? No, I don't think so. Let's pass in x, and then we'll create our model, which will be tf.keras.model, giving in the inputs as we specified, and the outputs as we specified. Alright, and then we'll compile it, model.compile. Optimizer will be Atom. Our loss function will change based on if it's binary or multiclass, so we'll call that loss. Include that again up here. Loss equals, we'll initialize it as sparse categorical cross entropy. And our metrics, today we're just going to use accuracy. And return that model after it's been compiled. Alright, and this should be the function that we'll use to generate each of our 3 models. So if I want to remember up here we have this thing. Okay, let's just place that back down here again. And so these are our classes for each of our target columns. Why don't we split with the train test split function? And I'm going to do it 3 times for each model. One for gender, which we'll call it x gender train, x gender test, y gender train, y gender test, train test split, our x, and our y gender. And we'll give it a train size of 70%. And then I'll do that again. Once we'll do it for the ethnicity values. So let me just select all these. So ethnicity, and then once for the age values. So I'll select all these. Alright. Oops. Okay. So now we have 4 of these for each model, and we can start building them. So, whoops. Oh no. Alright, this is actually, since I closed it out, this is actually a good time to switch our accelerator to GPU. Since we'll be doing a image classification with pretty intense neural network, GPU will speed up the training process substantially. Alright, and then we'll just run all as soon as this starts up. You can just hit this actually, run all. Alright, and let's mark this down, gender model. Alright, so our gender model is going to be, we're going to build it with the build model function we specified. And the number of activations, number of classes, sorry, is going to be 1. And there's actually 2 possible classes, but since we're using a binary cross entropy, we're going to be generating probability values, probability estimates for the positive class only, because that implies probability estimates for the negative class. So we only use 1 class. Then we need to specify the activation and the loss. Right, so we have 2 here, but we're only going to generate 1 probability estimate because it implies the other. Okay, then so our loss will be binary cross entropy, and our metrics, no, not metrics, what was the last one is activation. So I'll put that here, activation equals sigmoid. Alright, so this will be our gender model, and then we'll fit it. We'll store its fit history and gender history. Gender model.fit x gender train x y gender train. Validation split, we'll give it a 20% validation split. Batch size of 64. Epochs of, let's do 10 epochs. And that should be good. Let's turn off verbose mode. And why don't we include a callback? To help us converge. Alright, this looks good to me. So let's train it. Oh, forgot the comma. Alright, while that's training, we'll use Plotly Express to generate a graph of the training loss and validation loss. So px.line, and we're just going to get our data from gender history.history. This will be the history attribute of this. He's already done training. Power of a GPU. Then y is going to be loss and val loss. And labels, index will get mapped to epoch. Value will get mapped to loss. And then we'll just give it a title. Gender model. Oh, we have to show it. Alright, we can see that it's converged pretty nicely. It looks like maybe 8 or 7 would be best. Let's train it only for 7 epochs then. And when that's done, let's store the gender accuracy. Model.evaluate x gender test, y gender test, and index at 1. If we index at 0, we'll get the loss. If we index at 1, we'll get the first metric, which is accuracy. Alright. Model. This should be gender model. Sorry. Alright, we got an accuracy of 88% or so. Not bad. And we store that in gender accuracy. Okay, now we'll do the same thing for the other 2 models. This will be the ethnicity model. And let's just copy this. And we'll just change every time it says gender, we'll change it to ethnicity. And this one. Alright. And we're going to change the number of classes here. This will no longer be binary. This is 5 classes. We'll change that to 5. We'll make this softmax, and we'll make this sparse categorical. Alright. And let's train that for 15. And we'll get another one of these plots. This time it will be the ethnicity model. And we're getting it from the ethnicity history. And this one converges around 8. So let's train it for 8. And then evaluate. So ethnicity accuracy is equal to ethnicity model.evaluate on x ethnicity test y ethnicity test sub 1. And we get this one about 75%. Alright, and then the last one will be the age model. So for the age model, the age model, we have 4. Remember, we binned the data, so now we have 4 different classes. And we're going to do the same thing here, but for age. So just select all these again, and there. Age. This one will also be softmax and sparse categorical cross entropy, but the number of activations will be 4. So we'll train that. Oh wait, actually, let's do it for 15 epochs, just so we can get a sense of how long we should do it for, and then plot one of these again. This time it will be age and age. Alright, and this one probably around 7 or so. So 7 epochs. And then we will say age accuracy equals age model dot evaluate x age test y age test sub 1. And this one we get about 62%. Alright, so we have all three models done, and we'll take a look at the results. Which we'll just plot with Plotly Express. This time we'll make a bar graph just showing the accuracy values for each one. So fig will be px.bar, and the x will be gender, ethnicity, age, and our y, the values we'll get from gender ac, ethnicity ac, and age ac. And for our labels, we're going to map the x-axis to nothing. We don't want anything on the bottom because we already specified here. This is just the title of the axis, right? We don't want anything. And then we're going to map y to accuracy. Then color, we will specify the same thing. And title will be model performance. If we show that, should get something that looks like this. So pretty simple, but we're seeing that the gender model outperformed the ethnicity model and the age model, and the ethnicity model outperformed the age model. So I think that wraps up today's video. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell and leave any comments in the section below. I'll see you guys tomorrow. Have a fantastic day.